What's going on, guys? In this video we are going to see an example of Laplace transform using the definition. In this particular problem we have asked to find out the Laplace transform for this given function right here, and also we have the Laplace transform equation that is given by f of s is equal to integration 0 to infinity e power negative st f of t dt. Now what we have to do is we have to replace this f of t with the given function, and then we have to do the integration. That's it for Laplace transformation. Now let's go ahead and do that here. Here we have f of s is equivalent to 0 to infinity and then e power negative st, and instead of f of t we are going to replace sine 3t. So this is going to be sine 3t dt. To integrate this one we can use the integration by parts. First we pick up the u value. In our case that's going to be sine 3t, and then dv value, that's going to be e power negative st dt. And if you find the derivative of this one, this is going to be 3 cos 3t, and if you integrate this one and this dt, and if you integrate this one, this is going to become negative 1 of s e power negative st. Okay, and also to find the integration by parts we use this equation. Integration u dv is equal to uv minus integration v du. Okay, now let's go ahead and write this one in that way. Here we have u is equal to sine 3t and v is equal to negative 1 over s e power negative st, and if you multiply these two together, that's going to give you negative 1 over s sine 3t and also we have e power negative st, and that's going from 0 to infinity minus integration v du. Integration 0 to infinity, v is negative 1 over s e power negative st, and du is 3 cos 3t dt. If we multiply these two together, that's going to give us negative 3 over s cos 3t e power negative st dt. Now let's try to simplify this one. If you plug infinity, here we are plugging for t because we are integrating this one respect to t, so these limits of integration are for t. So if you plug infinity for t here, this is going to be e power negative infinity, and we know that e power negative infinity is equal to 1 over e power infinity, and e power infinity is equal to infinity, therefore 1 over infinity, that's going to give us 0. So this is 0, right? If this is 0, the whole thing is going to be 0 because we are multiplying 0 with everything. So this is going to be 0. Let's see what happens if we plug 0 here. If we plug 0 for t, this is going to be e power 0. E power 0 is equal to 1. And here we have sine 3t, and if you plug 0 for this t, this is going to be sine 0. And we know that sine 0 is equal to 0. So the whole thing is going to be 0, right? So this is also going to be 0. So 0 minus 0, that's going to be just 0. Now let's look at this part. Here we have negative 3 over s cos 3t e power negative st dt. Here again we have to use the integration by parts, but before we do that, let's go ahead and move this constant to the front. Here we have negative 3 over s. Here also already we have a negative in front. Negative, negative, that's going to make this one positive. So this is going to be plus 3 over s integration 0 to infinity cos 3t e power negative st dt. Okay. Now to do the integration by parts, we are going to pick up a u and dv value. Here our u value is going to be cos 3t, and then dv value is going to be e power negative st dt. And if you find the derivative of this one, that's going to be negative 3 sine 3t dt. And if you integrate this one, that's going to give you negative 1 over s e power negative st. Now let's continue this one right here. Okay, the whole thing is equal to f of s. Okay, f of s, and here we are going to have f of s is equal to this 3 over s multiplies everything. Okay, then inside of this one we are going to use the same formula. Integration u dv is equal to uv minus integration v du. In our case, this is cos 3t multiplied by negative 1 over s e power negative st. That's going to become negative 1 over s cos 3t e power negative st. then this is going from 0 to infinity, then minus, we are going to have integration v du, so this is going to be integration 0 to infinity. In our case, v is negative 1 over s e power negative st, and then du is negative 3 sine 3t dt. Negative negative, that's going to become positive when we multiply, so this is going to become 3 over s. Then we have sine 3t, so sine 3t, and also we have e power negative st, e power negative st dt. Okay, now let's try to simplify this one. Now let's see what happens if we plug infinity. If we plug infinity, this here we have e power negative st, so this is going to become e power negative infinity. As we seen before, this is going to become e power negative infinity is equal to 1 over e power infinity, and we know that e power infinity is equal to infinity, so 1 over infinity, that's going to give us 0. So when we plug infinity, this term is going to be 0, right? So here we are going to have 0, then minus, if you plug 0 for this one, e power 0 is going to be 1, so this is going to be 1, and here we are going to have cos 0, because 3 times 0, that's going to be 0, so cos 0 also 1, 1 time negative 1 over s, that's going to be negative 1 over s, so minus 1 over s, that's going to turn in this one into plus 1 over s. Okay, so this is for this one. Now let's look at this one here. Here we have 3 over s constant, so we can move that one to the front. So this is going to be just 3 over s integral 0 to infinity. Then here we are going to have sine 3t e power negative st dt. Now if you look at this one here, if you compare this one with this one, our initial one, this is integral 0 to infinity e power negative st sine 3t dt. Here if you look at this one, this part, let's use that different color. This part 0 to infinity sine 3t e power negative st dt. It's the same thing, we just switched this one here. E power negative st and sine 3t are switched, that's different, but it's the same thing, right? So instead of this one, we can replace this one. In that way it will be easier to solve. Okay, now let's multiply everything by 3 over s first. So this is going to be 3 over s square for the first one, and for the second one this is going to turn into negative 9 over s square. Multiply by this one, we can replace this one with f of s, so this is going to be f of s right here, and in the other side of the equation this whole thing is equal to f of s. So if we move this f of s, 9 over s square f of s to this side, this is going to become f of s plus 9 over s square f of s, and that's equal to 3 over s square. Therefore if we take f of s common, this is going to become 1 plus 9 over s square, that's going to be equivalent to 3 over s square. Okay, now we are going to move this one to this side. Let's use a different color because we have so many things going on here. Okay, if we move this one to this side, this is going to become f of s is equivalent to 3 over s square divided by 1 plus 9 over s square. If you take s square common denominator, this is going to turn into 3 over s square over s square plus 9 over s square. Okay, and if we can flip this s square to the top, in that way we will get 3 over s square times s square divided by s square plus 9. From this one you can see this s square and this s square cancels each other, so we will end up with 3 over s square plus 9, and that's going to be the Laplace transform for the given function, and that's how we do the Laplace transform using the definition. I hope this helps. Thanks for watching.